Welcome to Let's Make a Game Platformer, episode 47. This is the refactoring Saturday. In last refactoring Saturday, I was actually started working on the camera and environment refactoring, and I promised a pretty cool effect. However, I ran out of time to do this. So I know I'll do it today. So let's continue with pretty much what I did was extract the camera and environment into events. So both camera and environment is being extracted by events that is sent into the rendering entity. What I'd like to do today is show how to have an effect of picture-in-picture. So basically, like on your new TV screen, you can watch a program, and then in a small window somewhere in the corner, you can watch a different program and make sure you don't miss anything. So this is the similar effect I'd like to do. And I'd like to use this effect for the ghost. So in one of the levels here, let me find this level quickly. I think it was somewhere 6th or 7th. Maybe 8th level. Yes, it's 8th level, so let me change it. We have on the 8th level here starting. So what I want to achieve is that when you spawn the ghost here, I want in a corner, maybe right corner or left corner, I don't know yet, I want to spawn a small window that basically shows what the ghost is doing and where the ghost is. At a later point, I might even have some key that basically switches between this view and the ghost view being the main one. So you can imagine then that in some other level, this ghost might be on off screen that I cannot see it. And it would be nice to see, okay, what is the ghost doing? How should I move? Because it uses the same controls as the player to move the ghost. Okay, so how I need to achieve this is that first of all, I have to make the main rendering entity saying, by the way, I might include some picture-in-picture being drawn. And then what I do, I make the entity that I want to be that secondary rendering entity. So you have the main rendering entity that renders everything here, including UI and so on. And I want to have a second rendering entity that's going to be rendering only this ghost. Rendering the level from the ghost perspective. So looking at the ghost. So I have to have second rendering entity, and I would like to have this entity to actually be this ghost entity. So when a ghost is spawned, it will have this information that it's actually creating a picture-in-picture, and this will allow me to have the camera that is being created by this object to be centered on this ghost and other stuff like that. Also, when the ghost dies, the picture will go away, which is exactly what I want. So let's start off with it. So first of all, rendering entity that is used for the whole screen rendering has to have the picture-in-picture rendering component. So it says, oh, by the way, I might be drawing some stuff. This is just basically a flag kind of component. So it only says stuff like this, that it's drawing stuff, because we don't want the ghost to render picture-in-picture as well, and so on. So this is the main entity that's rendering pictures-in-pictures. Okay, so second thing I have to do is I have to enable the post-processor. So I have to have this profile enabled in the platformer in the gameplay context. I want to have here the picture-in-picture. Okay, so we have this enabled. And so the last thing I said, I have to have the ghost, which has to have the picture-in-picture source component, which basically says, I am an entity responsible for drawing a picture-in-picture. You can have multiple of those, and then each one of them will be on render stuff. And how it renders and where it renders is in here. So we specify the location on the screen. This is all in screen coordinates. So screen coordinates are from lower left being 0, 0 to upper right being 1, 1. So we have 0, 0 to 1, 0 and 0, 0 to So 0, 0 here. You can see when this is the whole screen is game screen. Here gonna be 0, 0. Here's gonna be 1, 1. Here's gonna be 1, 0 and 0, 1 coordinates. So, and size is also in the same coordinates. So let me define maybe location. Oh, by the way, I'm using here the converter as well. So I don't have to specify X, Y separately. So location is going to be, let's say 0.7 and 0.05. And size is going to be 0.25 and 0.25. So quarter of the screen in X and Y direction. So it's going to be from 0.7 to 0.95 because that's the width. And height is going to be from 0.05 to 0.3. So basically there's going to be 0.5, so 5% of the screen below it, 5% of the screen to the right of it, and it's going to be lower right corner, so somewhere around here. If you the whole screen will be here, and it's going to be actually quite bigger because it's going to be quarter of the screen, so something like this in case of this whole screen. And the last thing I have to specify is frame color. So the picture-in-picture doesn't look very well if you don't have a frame around it, and I can specify the color. Let it be 55. So this is also using the converter for color. Here we specify RGB and optionally A. I can have this is gonna be produced basically a white frame. That's a good start. However, that's not the end because this also has to return the environment and also has to return the camera. So let's for now use these two camera and environment, so the normal one. So basically it's gonna render the copy of the screen on in the picture-in-picture. So let's give it a try. So spawn the ghost, and here I have. Okay, a couple of things. So first of all, background is black. That's because our main rendering entity, so this all works. Main rendering entity has a background color component, and our ghost does not. So let me copy this one as well. And another thing here is that we are rendering the UI in here. That's probably not what we want to do. So let me fix this, and the way I fix it is I'll modify the UI renderer to require render UI component. So let me change it's called stage UI system, and in the render UI it will require, I'll introduce, so this system is in the gaming package, gaming module. I'll here introduce the component, renders UI component. And this system is going to be called only if the rendering entity has renders UI component. Okay, so what is going to happen now is that I'll add this component to the main rendering entity, but I will not add it to the ghost, and therefore the main entity will render the UI and ghost will not. So let's check that, if that's what's actually happening. Okay, our menu rendering entity also has to have this because it's not rendering UI anymore. Okay, so we have UI and we have UI here. However, our ghost is rendered on blue, so the normal screen, and has no UI, so we don't have this small stuff here. We're almost there. So the last thing we need to do is to make sure that the focus is not on the player, but on the ghost. So first of all, I will modify the ghost prefab to remove the camera focus. I was planning before to have like the main camera be containing both, showing always both of the entities, both player and ghost. But however, instead I will have this picture-in-picture, and then I don't have to do this. So, however, I have to use a different camera. So let me create a new camera here. In the gameplay, where is the focus-based camera? Rendering. Okay, so in here I'll have a new camera component, and it will be focused on entity, track entity camera component. So it will track the entity that it is on. So in our case, this component is going to be on the ghost, so it will track the ghost. What we'd like to have is Z and distance Y, sure. And so I'll modify the ghost to have this instead. And I have to create a system that's going to be doing this stuff. So we can copy this one. Track entity camera system. And in here, I need to have track entity camera component and location component. Okay, so we don't need this. We do need this. And no need for this. No need for this. And it's gonna be location X, location Y plus camera distance, not location, get Y, get X, location, get Z plus C, and look at, it's gonna be X, Y, distance C, and this is going to be C. X, Y, and Z. Up and update and OK. So now this entity has different camera, and this camera should be following the ghost. So let's take a look at that. Okay, as you can see, ghost is the center of attention here. And there's a couple of differences you can see as well. So I'm not sure how well you can see it. Let me make the screen larger. Oh, I have to change this. The frame has disappeared, and also this has disappeared. Anyway, so also it's not being resized correctly. Okay, so what's happening here is that maybe let me fix this first. Okay, I fixed the issues, so now when I resize, it's resizing properly. So the differences here you can see is that it's not very well visible, but okay. So when I'm looking from the perspective on the main screen, from the perspective of the player, this is very well lighted by the light that is coming from the camera. And this here is going to be dark. And in here, it's opposite. So stuff on the top of the layers that normally would not be lighted because the light is probably around this place. So basically, we have different lighting from the camera for this one, and this is different from this one. And the reason for it is that the environment that is being returned by the call is using the camera that is sent over. And since we are using camera in different position, the shift of the camera lighting for the platform and environment command is based on the camera that is used by the ghost. And I think this is a good thing. So we have lighting is different for the main screen and the ghost, but it's probably okay. because otherwise, if the ghost were somewhere where it would be away from camera, it might not be very well lighted and might be very difficult to see. Okay, and there's a little bit of time left, and I'd like to maybe show how this picture-in-picture is achieved, because I think this is interesting thing to see how the entity system is used in here. So this is a post-processor that is responsible for all the rendering of the picture-in-picture. It seems very difficult. It's not. I'd like to I'd like to show it to you what's happening. So first of all, in the initialize method, I'm getting an index of all the entities that are rendered as pictures in pictures. So in this case, it's going to be the ghost or more ghosts or whatever. I have a shader here. This is some kind of OpenGL stuff and libgdx stuff. I don't want to get too deep into this here. So basically, this is a shader that allows me to copy one off-screen buffer, so one off-screen image of a frame, to another. And a model batch that allows me to do the same. So this is model batch, something that is used for copying the pixels from one off-screen buffer to another. And last thing in here, I create a shape renderer, which I used for rendering the shape. Pretty simple. Okay, now we have the only method in this class that is doing anything that is remotely associated with rendering is a method that basically in the post-processor rendering, it basically checks if the rendering entity has this component. So for the main component, this is going to be called only for the main and rendering entity of the game. And if so, it does the following. First of all, it gets the pipeline and gets the current buffer. So the main buffer on which everything is rendered off screen. We get it here, and I get the camera that is used for rendering the main screen. And from that camera, I can extract width and height of the screen. And I make sure that the shape renderer is updated with the width and height. So this is what was missing before, as you can see. I had to modify it because it was missing, and the shape rendering basically was using the old width and height of the screen rather than the new one. Okay, so we have this part, and now I iterate through all the entities that want to be rendered as picture-in-picture, and I extract their position, so the location, size, and frame color. Then I calculate the width and height of the small window that we want to render, and I create a new frame buffer, so the new off-screen buffer for rendering stuff with this width and height, and also specifying that we want to have all the attachments, so depth and stencil buffers. Then on the rendering pipeline, I'm saying, okay, right now I want you to render on this buffer, on the picture-in-picture buffer. Okay, then so this is the nearest pass to pipeline. Then I say I want to do something with this buffer, and what I do is basically delete everything from it. So I basically fill it out, the color and depth, with a black color. That's why by default it was black before I added the background stuff. And then here's the very, very interesting part. So rendering engine is, if you remember, is something that is responsible for doing all those events, post-process rendering and so on. So at the moment, what this class does is it does very similar stuff to what we do in the picture-in-picture. So basically, it creates a new buffer with the width and height of the screen, the whole screen, sets it as the current one, and then cleans it. So the same what we did in there, cleaning the buffer, which is doing the same stuff. And then it calls render entity method, which is here, passing the pipeline, the entity that we are using, the main entity for rendering, and width and height. And then it copies what is the result of the pipeline onto the screen, actual screen, the physical screen. And then it gets rid of the current buffer. Okay, so we have to do basically the same thing, but for the different entity. So that's what we are doing. We are calling the rendering entity here. And then you can imagine that in the background, it basically starts the whole rendering pipeline, just not for the main screen entity, but for the picture-in-picture entity, so for our ghost. with this width and height and rendering to this frame buffer. And finally, when we are done with this, so you can now imagine that this buffer, or actually the buffer that's in the render pipeline, has all the pixels that we have in this small window for the ghost. We finally have to copy the stuff onto the main current buffer, so the buffer that is used to render the whole screen normally. So what we do here, we basically create a model builder and we set up the rectangle that is going to be the size of what is defined here, so the location and size. And this is all in screen coordinates. So as I remember, screen coordinates are lower left is 0, 0, upper right is 1, 1. So we create basically a rectangle specifying from location with the size and with the z coordinate of 1 and with the normal of 0, 0, 1, doesn't matter. Okay, so now we have the model here. And I create an instance of it. I could probably extract it to make it faster. Maybe I'll do it some other time. And I also, so this is the tricky part. So on the copy shader provider, I specify, by the way, the source for the copy is at this, at index 0. And then I activate this texture at index 0. And I bind this, the active texture of 0 binds to the whatever is in the current pipeline buffer. So as I said in here, after this line, we end up with the render pipeline having current buffer, which contains all the pixels that we want to copy, that we want to have in the small picture inside of the rendered for ghost. So this buffer contains all the information, and I pass this texture to the copy shader provider, specifying this is what I want you to copy. So this is these lines. I want to say, copy shader provider, this is the source of the copy. And then I specify tell shader provider, by default, basically copy shader provider overrides the whole screen. However, in here I say, by the way, I want you only override this part of the screen, so from location and the size here. Then with the current buffer, which is the buffer that we are normally before rendering on, so containing the main screen pixels, I say, okay, I want you to copy the stuff onto the current buffer. And finally, I want to draw lines, actually a rectangle here, with this color, with this coordinates. Finally, I say, okay, I'm done with drawing on the current buffer. And I get rid of the pipeline buffer here, current pipeline buffer, because it's no longer needed. I'll discard it and just return to the pool. So we don't use a lot of memory that we don't need. So we get rid of it. Finally, I get rid of the copy model here that was created. And finally, after all the picture-in-picture are rendered, so this is repeated for every picture-in-picture source. Finally, I say, okay, we are back to rendering on the main screen buffer. Okay, and that's pretty much how it works. So thanks to the fact that we are doing all the rendering using events and entities, I can do such amazing magic here with just a couple of lines of code. Yes, it's not an easy code because, well, it's OpenGL. OpenGL by itself is not something that you should be sitting down and doing on your first lesson, but once you look past this part, you can see that it's actually pretty simple. I just use the rendering pipeline for rendering different entity, the ghost entity, and the ghost specifies its camera, and ghost specifies its background, and specifies its environment, and so on and so forth. And then I just have to copy it onto the main screen, and voila, I'm done. Okay, that's it for this episode. Make sure to like it and subscribe to my channel. You can also follow me on Twitter. A link is in the description. Thanks for watching. Bye.